are the maybe frequencies, wavelength, amplitude, how does all of these things matter? Okay. So these were the basic things which are bit like you can say building blocks during your wireless studies, right?
Yeah,
You tell me one thing. Into your project, you have like Cisco, which series controller you have?
it was 5520.
5500 series. Okay. Okay, okay, got it. So in our lab, it is 5508.
Yes, yes, no problem.
Fine. So, yesterday I was talking about couple of the concepts, right? Service set, basic service set, extended service set. All these terms are, I hope you are okay with it, right?
Yes, yes,
Now, now I am talking with you one more fundamentals named as split MAC architecture. Have you heard about this?
yes.
Okay. So can you give me some overview, like a little bit, how much you can give?
I just heard about it, but I'm not go in depth in that. So it's long time.
Right,
But
right.
I
That's right.
yeah,
That's right. That's right. So what happened is, let me share a PPT with you. Give me a minute. Okay, let me find it out. Are you able to see my screen?
yes,
So here on this screen, if you watch it out, okay,
yeah,
you can able to see how typical wireless solutions look like. Okay.
yeah,
So if you see, we are having the core, we have the AP, we have the wireless controller, and we are showing you the Cisco three-tier architecture. See, earlier there was the three-tier architectures in place. Nowadays, system is changed after the SD-WAN thing and converged access thing. But yeah, I am just talking about the typical our wireless stuff. So if you
uh,
see this layer, this complete layer is access point.
yeah,
Okay? And access point configured on which layer? Access layer.
yeah,
When I am talking about three tier, so access layer distribution core, with respect to that, I am asking you. Okay. So it will be just connected with your access layer. So it can be layer 2 switch, it can be layer 3 switch. Right.
yeah,
So light after the lightweight APs, there are some clients which will be get associated with this. Okay.
yeah,
Similarly, you can see with every device. Now, when traffic will come from your 802.11, it will need to convert on 802.3. Who will convert that? Any idea? Any guess?
yeah. The switch.
No. Switch will never intercept this.
Okay,
Any other idea?
the router.
Okay. It will go to the controller.
Okay, yeah,
Okay. Only controller has the capability. Again, conditions applied. Okay. Nowadays, there are lot of switches are there in place which can do this this scenario. But again, that are some special switches, not the legacy switches.
mm-hmm.
Okay. So that is where the concept comes with the split MAC architecture. Okay. So
Okay,
split MAC architecture means what? That see. There are many things to consider when you deploy your multiple autonomous APs in your environment. If you have multiple APs which are working in the autonomous way, they will do this conversion by themselves. Okay, you need not to be dependent upon the controller. Are you getting my point?
Yes, yes, yes.
So if it is autonomous AP, it will do all the conversion. Like here,
Yeah,
it would be 802.11. Here it would be 802.3.
yeah,
But when you have multiple autonomous AP, it means the management is not properly designed. Although in Meraki there is a little bit different, view, but we are talking about Cisco. Let me just focus over here. Okay.
okay.
So administrator must manage every area by working on the specific, autonomous AP. If we need to increase the transmit power, we need to go into that AP. We need to do that. If we need to avoid the overlapping, we need to go there and need to change the channel. Right? Remember, yesterday we talked about 2.4 gigahertz that we have only three channels which are
Yes,
non-overlapping.
yes.
So the autonomous AP architecture, I will say, is the biggest concern when it comes to the network scalability. Okay. So if your
Okay.
company is really very growing, the AP in the autonomous AP architecture is really very complicated. So we use what? We use LWAP. LWAP stands for lightweight access point.
No, sorry, your voice is breaking a little bit. I cannot hear you.
Zoya, is it same for you also?
No, sir.
Um, Maybe Mohammed, there is some issue your side.
Yeah, it's okay now. I can hear you. Yes.
So I am talking, it is lightweight access point. Okay.
Okay.
Lightweight access point. We can say LWAP or we can say LAP, interchangeable term.
Mm-hmm.
Okay. Now, what happened is when you have LWAP, their only part, I will, talk about it later on. I will show you in the practical also. But their only part is that they will deal with client. Rest all of the configuration. If we talk about the authentication, if you talk about the SSID, if you talk about other parameters, that will gonna come through the controller to the LWAP or lab. Okay, so it does not has its own mind, you can say. So with your split MAC architecture, we required a WLC first of all. Okay, when we are talking about WLC, WLC always connect where? On the core. And
Okay.
in between WLC and core, there would be a trunk. Why trunk is required, you will understand in our upcoming classes. Okay,
Okay.
but for now, you can just understand we require a trunk. This thing, the connection between the AND switch and the lab can be the access connection. Okay, access port it can be. Only one VLAN is good. We don't require much VLAN.
Okay.
But even then, we have multiple SSIDs. If those questions are coming into your mind, it's all right. Hold for some time, you will understand. Again, there are some condition applied because there is one more mode named as Flex Connect. Okay, which is again a little bit exception to this. But I will be gonna cover everything step by step. I cannot give
Oh,
you everything in one go. Okay.
yes, yes.
So this thing is clear that it would be an access port. Sorry, this would be an access port. This is in trunk port. It will be on the core controller, and
Mhm.
your lightweight AP will be connected to the access port. Fine,
Okay. Yeah.
good. So this is one thing. Now, this LWAP will take care with respect to the client. Okay, collecting the signal quality information will be done by these LWAP.
Mm-hmm.
Monitoring the radio channels for your rogue APs, these LWAP. Encryption and decryption will be done by these LWAPs. Okay, but we will be talking about those points soon. But let us say if this user is going or roaming, okay, somewhere else, so these labs are responsible for connecting. But in the background, there are a lot of things. Who will handle that? Controller.
Okay.
Now you try to understand one thing. This lab or sorry, LWAP depend upon the controller completely with respect to any of the management task. Okay,
Okay.
and this architecture is more better than your ESS as well. And since the client information is available over here, client information is available over here also, right?
Mm-hmm.
So it is bit like they talk this architecture as split MAC. Why? MAC is split between these two devices. Okay,
Yeah.
clear?
Yes, yes.
Okay. Now, when I am talking about this, I need to talk about one more point here. As you can see that one tunnel is getting created between your controller and between your access point. This tunnel will go from these devices only like this, right?
Yeah.
They will create a tunnel. This tunnel named as CAPWAP. C stand for control and provisioning, okay, wireless of wireless access point. So control and provisioning of wireless access point. It is an open protocol, right? Earlier, Cisco created it. It was the proprietary, but nowadays it's open. Help WLC to manage all the labs. Okay. So this
Yeah.
tunnel will get created here also, here also, here also. All the labs will have this tunnel get created with the WLC controller. Is this fine?
Yeah.
So wireless network, when you talk about WLC and lab, there are two CAPWAP tunnels. Okay.
Mm-hmm.
And the minimum requirement to build this tunnel is like you need to have the reachability. How you can check the reachability? Through the ping pong, maybe trace, you can just check. Okay. And this CAPWAP tunnel is responsible for your control messages, which are can be packets to configure and manage the operation of lab, right?
Yeah.
So it has the data encryption of the corresponding lab which connect with the WLC, and it uses a special port that is a UDP port, okay, UDP port 5246 for your control messages because it need to control the labs. On the other hand, data will also go. Why data will go? As I told you, who will do the conversion? 803 from 80 to 11. Who will do?
The controller.
WLC.
Yeah.
So data will also travel, right? So data traffic traveling to and from the wireless controller and the clients, right, will go through the CAPWAP data tunnel, right? Again,
Okay.
your data will be encrypted using DTLS, right? So DTLS is a protocol, Datagram Transport Layer Security Protocol, right?
Okay.
And it
Yeah.
uses the UDP port 5247. Is it fine?
Yeah.
So once your CAPWAP tunnel is established, okay, between the lab and the controller, very first time. So it will pick all the configuration from the controller. It will get booted up also with the new image if the image upgradation is also required. Getting my point? So all the control thing will be done from there only. So once your CAPWAP tunnel is established, configuration of the firmware can be pushed from the controller. This is also responsible for gathering the different statistics, right? Statistics like what? Like okay, statistics like I am running on channel 6, but my neighbor is running on channel 11. So it has the statistics, which the statistics will go where? To the controller. And on the basis of these statistics, controller will form a complete RRM solution. Are you getting my point?
Yeah.
So it is really very important, and control message will exchange between your WLC and lab through this encrypted tunnel only. Okay. And in this, when this tunnel will get formed, it has its own discovery and join process also. Okay. So
Mhm.
these all are the overview of the tunnel. Is there any doubt so far?
No, that's okay. Fine.
Good.
Yeah.
Okay. So one thing, there is something named as mobility agent, which is responsible for terminating your CAPWAP tunnel between your AP and WLC, and it also maintain the user and client database, bit like the client is from here going over here. Okay, so database will get changed, right? So
Yeah.
first it is associated with AP1, then it is associated with AP2. Maybe if you wanted to push QoS, anything. So these mobility agents, these are named as mobility agents. These are named as mobility controller. Okay. Like mobility controller is responsible for your roaming, for your radio resource management. Okay. For your wireless intrusion prevention and deal with the guest access. Okay. So all those things will be get formed when your CAPWAP tunnel is established.
Okay.
Okay. So this is named as bit like mobility controller. These are bit like mobility agents. Okay.
Yeah.
So when I'm saying about the mobility agent, it can be either a switch or a which has the wireless module running on it. Okay. Or maybe you can say AP, because there are a couple of the switches also nowadays which are having the wireless module inbuilt. So
Yeah.
they will work as the wireless, like 3850 switch. Okay,
Yeah.
fine. So no doubt so far, right?
Yeah, it's okay. Oh,
Good, yeah, good. Ah, let me just talk about one more term, then we will proceed because we are talking about this. There are two terms, POA and POP. POP means point of presence. POA means point of attachment. Okay. POP will never change. It will be same. POA can be changed whenever the client or the user or the station roam from one, let us say, this AP to this AP, and this AP is on some WLC too. Getting my point? So
yeah.
in that case, it will be gonna show you that okay, and this client is now associated with WLC controller 2. Rather than WLC 1, it will go to the WLC controller 2. Any doubt?
No, it's okay.
Fine. So this is your split architecture. Okay. So when you are designing your Cisco stuff, you can have ESS, as I told you. You can have split MAC, and there is one more thing which will come into the picture, and I would be going to talk about it, which is Flex Connect mode. Have you heard about Flex Connect mode ever?
Yeah, I heard about it before. Yeah.
Okay. So the Flex Connect mode is what? Like when your AP is not completely acting as lab. Okay. Some decisions it can do by itself. So you can say neither it is autonomous nor it is lab. It is somewhere in between autonomous and lab. Okay.
Yeah.
So that is named as your lab. Sorry, Flex Connect.
Yeah. Yeah.
Okay. So when it comes to the design, there can be different design describing as below. Like I told you ESS, I told you Flex Connect mode. Okay. Split MAC is what? It is bit like your centralized, centralized network design. Okay. This is your Flex Connect mode design, right? Then
Yeah.
there is something named as nowadays SD access design. Have you heard about this SD access design?
Yeah.
Okay. So in central design, you are aware that there would be a controller and there are the access points. All the access points will be having the LWAP. Okay. So
Mm.
this kind of design is really good if you are doing it in the like a separate data center. Why? Because you will be having your access points already there. You would be having your controller also already there. So that is good. If you have the controller and you have the access point on the same data center, good with your split MAC or maybe centralized network design. But let us say if you have a lot of branch locations and there is some kind of requirement that you need to deploy the remote office. Okay, there is remote office deployments requirement is there. So in that case, you need to configure the API at the every branch or the remote location or the remote office, right? But they need to connect with the wireless controller through the wide area network or through the LAN or through the your wide area network, MPLS, SD-WAN in any case. Okay. So in those scenarios, it cannot be the centralized thing. There you need to have Flex Connect mode in any case. Okay, because
Okay.
this kind of wireless solution do not require a specific WLAN controller in each site. Here the management of the configuration access point will be done from the central location one time, and this type of solution is really cost effective when you have small networks separating around the, maybe you can say, controller. So in when you have the Flex Connect design, you have the WLAN controller on the central side, but it is in the sharing basis. So let me just create, maybe you can able to relate. Let us say this is your DC. In your DC, you have the WLC controller, and there are lot of remote sites. Lot of remote sites. Okay. And these remote sites has AP, but these APs need to interact with the controller. So it is not good that every site traffic is going to the controller over the WAN and then traffic is coming back and then the users can interact with each other. That is not good. So in that case, what we can do is we can use Flex Connect. Okay.
Okay.
So you can use this design. Then the solution SD access design is the integrated solution, right? Where user can benefit from both of these architecture, right? So they can have the wired or wireless both altogether, right? Maybe you have heard about the fabric control plane. So
Yes.
it will be getting created your fabric mode WLC, fabric mode APs, where the latency will be really very low, But again, cost is the involving factor over there. So people need to think about during the same. Okay,
Okay.
fine. So now let me talk about one more term, which is again important term with respect to the wireless controllers named as RRM. Have you heard about it?
Yeah.
So this is radio resource management, very critical feature. Okay. It was introduced originally as the airspace APE and the controller, which become the part of Cisco later on because of the acquisition happened in the 2005, right? But
Yeah.
originally this was generated by airspace, right? Airspace formerly, if I say you, it was the Blackstone Networks, separate company, network hardware company, founded in 2001. Okay, which was manufacturing your wireless access point and controllers, right?
Yeah.
And the company developed your AP controller model for fast deployment, like your LWAP, which was the predecessor of the CAPWAP. Okay,
Yeah.
before CAPWAP, there was what is that? Lap lap web, something like that. Okay, so this is your airspace, which merged in 2005 in the Cisco. Fine.
Yeah.
So I was talking about RRM, radio resource management. Nowadays, if you are using 5500 series of stuff or any radio resource management is a very critical feature in the Cisco wireless controller. Really play a very vital role in optimizing and you can say or perform optimizing your performance or maybe efficiency if you need to induce. So it is really very important. By default it is enabled on every device because every device need to be self optimized through the auto RF radio frequency, right? So
Yeah.
RRM is responsible for managing various aspects of your radio spectrum, such like your channel assignment. So which channel need to be assigned? Who will check? RRM will check. Like your power level. Power level. Are you getting the point? Why power level? We need to change.
Sorry again. What?
What do you understand by the power level?
The milliwatt power level 25, I think, something like that.
So power level is what? Let us say if you have the AP.
Yeah.
This AP has some area named as BSA, what we discussed yesterday.
Yeah.
Now, if you need to increase this BSA, you can increase the power.
Yes.
But again, you cannot increase such a power which is beyond the maybe which can cause some harmful effects that you cannot do, right? But if you
Yeah.
are increasing the power, your signal will get increased. So that is the
Yeah.
power level. And who will check the power level? RRM will check the power.
Uh, yeah.
Then one more point, very important, interference. Interference management or mitigation, whatever you wanted to say, everything will be taken care by your RRM. Okay. So Cisco
Okay.
implementation of RRM is designed to automate these. They will simplify these tasks for you to ensure the best possible wireless network performance. And if you ask me what is the RRM, it is bit like you can say different combination of algorithms to provide a comprehensive management solution. Okay.
Uh, yeah.
So when you are creating RRM, you can there is a complete hierarchy. I will say you can create first of all a RF group. Okay, there can be different RF group. Every RF group has a group leader, and they will be having the neighbors, RF neighbors. Okay, so group leader means like you can say okay, first RF group. RF group maybe you can say a logical container. Okay, bit like your logical container that have all the devices belonging with the same RF management. Okay, because when your devices are getting growing, okay, you don't have a single WLC, you can have the multiple WLCs, right? So that is
Yeah.
how first you need to create RF group, then RF group leader, then RF group neighbors, right? So let us
No.
say you are giving some kind of name. Okay, any name you can give. I am just giving the name like NetMinion. Okay, this is the name of the RF group. So now you should have at least minimum two, leaders, so that if one leader is getting failed, second leader can take the like seat, and it can take the steers. Okay, so your RF group leader will manage multiple RF neighbors. So if you have multiple RF neighbors, which are again nothing but your WLCs and your APs only. So the thing is, it is the way to check like if I have everything is in properly placed or no. Like what? Like your DCA, as I was mentioning, dynamic channel assignment. So RRM use this DCA to automatically selecting the best possible channel for your access point based on the RF condition. It continuously monitor the RF environment for your interference and adjust the channel assignment accordingly. Maybe if your AP currently is running on channel number 1, it can switch on the channel number 6 if there is more interference and it has less. So it all depend upon the DCA, right? Like I
Yeah.
talked about TPC, transmitting power control. So RRM will again dynamically adjust the transmit power level of the AP to ensure optimal coverage and minimum interference. It can increase or decrease the power level as needed to maintain your stable RF environment. Then there is something named as CHDM. Okay, CHDM. CHDM stands for coverage, hole detection, and mitigation. What happened is, let us say there is an AP. There is an AP. Okay. This AP area is like that. This AP area is like that. Now, one client is here. This client even cannot interact with this, cannot interact with this. There is a hole, you can say. This hole need to be fulfilled. Maybe the area need to be get extended over here or over here, right? This is
Yeah.
your hole. So RRM can detect the coverage holes over the areas with the poor wireless coverage and can take corrective actions like adjusting your power level, maybe channel assignments, whatever, to fill these gaps. Okay. Then if you talk about the interference detection and mitigation, RRM can identify a source of interference both within and outside of the wireless network and can make the adjustment to mitigate your uh, the impact of the interference on your performance. Then it can do the load balancing. It will optimize your client roaming. Okay. It will check the channel width and all of the stuff. And but obvious, it will do the logging and reporting also. Any doubts so far?
No, it's okay.
Let's now jump to the very important topic. There is an AP, there is an controller. So whatever knowledge you have, you need to just tell me how an AP associated with an control. Very beginning, very basic step. Actually, very first step I will say. So what happened? How your AP will go and will talk with your controller. Are you like question is clear to you?
Yeah, I'm thinking.
It's all right. It's all right. You just think, okay, because on the basis of that, it will be the interactful session.
I think it's like handshake.
Handshake, yes.
Yeah, the AB will send the message to the wireless controller, and the wireless controller return it back to the AB.
Right. You are very much right.
Yeah.
Now, one question comes into the picture. How AP is aware that where I need to go? Who is my WLC?
Okay. I think the SSID or no, no, not SSID.
Right. So let me tell you first SSID. AP will broadcast some information
Yeah,
that is named as SSID, and client will listen to that SSID and can interact with AP. So SSID is a term which will come into the picture when AP and client communication happens.
yeah,
But currently, I am talking about AP to the controller. Okay, let me tell you. Right.
yeah, yeah,
So there is a really very big process. Okay.
yeah,
So when it come, okay, it is named as AP discovery process. Majorly, I can just divide it into um, four steps. Let us say this is my AP. Let us say this is my controller. So first of all, it will send the discovery request. There will be discovery response. So I am writing down discovery request and response, right? Second thing, there would be a join request and there will be join response. So I'm just writing down over here join request and join response. As I told you, it seems very, you know, simple, but it's not. There is a lot of things in the background. Let me talk about them step by step. So what happened is there are two things. One is control plane. Okay. Like discovery and join request and response where data traffic is your application traffic. So have you heard about the term OEM?
mm,
Original Equipment Manager. Like it can be Cisco, it can be Meraki, okay, it can be Aruba.
yeah,
Different OEMs are there, original equipment managers. So when your OEM manufacture any AP and WLC, they use some certificate, okay,
yeah,
which are digitally signed by some of the CA. There can be some root CA which are signing these, okay, the certificate authority you can say. And these are named as MIC, manufactured installed certificate. Earlier they were self-signed, but nowadays because as digital world is getting expanded, we cannot have the self-signed certificate everywhere. We are utilizing some of the CA. Okay. Now
mm,
these certificates are really very important when thing when these two devices need to communicate with each other. First thing is you need to understand about the MIC, manufactured installed certificate. So these certificates are bit like maybe you can say authentication so that no other fake AP or WLC can associate with each other.
okay,
Getting my point? So
yeah,
AP and WLC project these certificate to one another to verify their identity. And after that, only the DTLS tunnel, what I was showing you earlier, will get formed. Otherwise, it will not get formed. So when you are saying about handshake will be made if there is no anomaly in between.
Okay.
Otherwise, your handshake will be unsuccessful and your join process will get terminated.
Yeah.
Okay. So AP registration is really a very big process, as I was mentioning you, and there can be a lot of steps. Okay, which now let me talk one by one. Step number one. AP will begin with the WLC discovery. Here I am putting star. The star is the same question what I asked you from your answer, that how AP is aware which is my WLC. That thing I will tell you later on. But let us say it is aware. Okay, by some way it is aware. So AP will begin with WLC discovery and join phase. So AP will send what? It will send CAPWAP discovery request. This part is clear.
Yeah.
Step two, there can be one WLC, there can be two WLC, there can be three WLC or more WLC on the same channel or LAN, you can say. So any WLC who is listening to this CAPWAP discovery request will send. So WLC will send the CAPWAP discovery response will be sent by whom? By WLC.
Yeah.
This was generated by whom? By AP. Okay. Then
Yeah.
step number three. Your CAPWAP response received from WLC, AP will select like which WLC I need to choose. Let us say three WLC sent. So it need to choose. Okay, again, as I am telling you, I will be coming like which WLC he will choose. That I will be gonna talk about in a moment, because there are a lot of hidden things again come in between. But currently I am just
Yeah.
talking the overview. Then fourth,
Yeah.
AP will send the CAPWAP join request. So this time AP will send CAPWAP join request to the WLC. And this WLC was expecting this join request. Okay. So
Okay.
when it will receive the join request, you can see that it will send the join response to the AP. Okay. And AP and WLC at this time will complete the discovery and join process. The validation on both AP and WLC end will be done using mutual authentication mechanism through your MIC, and a CAPWAP control plane tunnel will get established between the AP and WLC. Is this okay for you?
Yeah. But
Okay. Now let me proceed further. First challenge is to find where to send this CAPWAP discovery message. Right?
yeah.
That question is still open. We have not closed that question. And for the same, one more point come into the picture, named as AP will go through some process named as hunt process. To find a WLC. And here also couple of the points which will come into the picture. The very first point which come into the picture, AP issue a D sorry DSCP request. So AP issue a DSCP discovery request for what? For finding out the IP address. So this is a new AP. It will, you are aware about DSCP protocol, yes or no?
Yeah, yeah.
So you are aware about how DORA work, right? So it will just generate the request, okay, to
Yeah.
get the static IP address, right? So first
Yes.
thing, it will have the IP address, AP, right? And
Yeah.
within the DSCP, okay, I will come to that option, but you should not get confused. Maybe let me first go further. Now, AP can send a request to the broadcast address. What is the broadcast address? 255.255.255.255. Okay,
Yeah.
to find a WLC. But the thing is, let us say this is your AP. This AP is connected to your layer 2 switch, right? And
Yeah.
there is an layer 2 switch further. And from this layer 2 switch, there is WLC connected. I am just giving an example. It will generate a broadcast. This broadcast will go over here. This broadcast will go over here. It will say, yes, I am the WLC. You can respond to this AP, and it will respond to the AP, and post that a tunnel will get formed between the WLC and AP, right?
Yes.
But as I told you earlier, AP connected where? AP got connected to the access switch. Let us say it is a layer 2. Post layer 2, there can be a layer 3. Then there can be a core. After the core, there is WLC. Yes or no? When
Yeah.
it is sending the broadcast, this broadcast will go over here and it will drop. So this broadcast traffic will never reach to the WLC. So this point can be failed. Getting my
Okay.
point?
Yeah.
Clear to you, right? In which scenario it can pass and in which scenario it can fail. And generally it should be failed because layer 3 broadcast, layer
Okay.
3 packet will drop the broadcast. Okay.
Yeah. Good.
So when it is sending the broadcast traffic, it will use your UDP port 546. But the thing is, your AP and WLC should be in the same subnet, same LAN, or you are aware like what are the things. Okay.
Yeah.
Hey, Mr. Mohammed. So
Yes.
should we start?
Yeah. Sure.
Okay. So I was just describing about AP discovery process, right? Like
Yeah.
how very initially when you plug your AP in your network, what happened actually, right? So
Yes.
what all steps it will go through that I am describing about, right?
Yeah.
So you can see there is AP DSCP request which will receive the AP will get the IP address. Else, you can take the console of AP and you can statically put IP address also anytime. But I'm not talking about static part currently. I am talking about dynamic stuff. Okay.
Yeah.
Okay. These 2 points are clear to you. What we discussed.
Yeah. Yeah.
Let me proceed then. Point number 3. Okay. So point number 2, layer 2 broadcast. Sorry, layer 3 broadcast I talked about, right? Point number 2. I talked about layer 3 broadcast, which is 255, 255, 255, and 255. Point number one was IP address. Okay. Point number three. Uh, you can have something in your DSCP. There can be different options which you can configure. One of the option is named as option 43. Okay.
Yeah.
So DSCP option 43 in the DSCP offers some message. So when a Cisco Unified, you have Cisco Unified architecture deployed into your network, and lab wanted to communicate with WLC. So when lab go to the, let us say, switch, and from this switch, let us say this is your DSCP server. Okay.
Yeah.
So this lab will say that, okay, I am Cisco access point and I want, option 43, whatever value is there, you tell me. And it can provide a value. That value is describing that, okay, what is the controller? Who is the controller? Okay. So we can have the controller information configured in option DSCP 43. Is it fine?
Yeah.
So this is your option 43, which can configured in your environment when you have the like DSCP feasibility over there. Okay, one point. Second thing, you are aware about DNS, what the DNS is?
Yeah.
Domain name system.
The one names. Yeah.
There is an entry, okay, that is Cisco controller. Maybe it is Cisco CAPWAP first. Cisco CAPWAP, then controller dot whatever your domain is. Okay, whatever your local domain. Let us say in my case it is NetMinion, so I am just putting netminion.net. But it can be any local domain, right? So
Yeah.
AP can generate a DNS request that I wanted to go over here. Now again, here you just consider that this request is going to the DNS, right?
Yeah.
So AP will try to resolve this specific name, and this name from here to here is the common name. Only the domain will keep on changing depending upon your environment, right? So
Yes.
AP can discover controller through your DNS as well. Now, for the same, on your DNS, there should be entry, right? With
Yeah.
this particular name, there should be entry. Let us say 1.1.1.1 is the IP address. This IP address will be where? On the controller. Are you getting my point?
Yeah.
So here also using your DNS, it can get the information about your controller. Then if you have an old AP, old AP means, let us say it was into the branch location A, but now that branch location is no more there. Okay, all the work is completed. Maybe there was some kind of work which we need to be done, and that is completed. It is no more there. This AP now you are bringing somewhere else. So whatever entry was there earlier, maybe you can say previously non wireless controllers, It can remember up to 24 IPs. Okay.
Yeah.
So if previous all things are not there, it will send to all of them, whatever previously configured. Right?
Yeah.
Then the very robust part, sixth, is you can statically configure this. So before, like, let us say, before shipping, you can just have the console of that AP. You can configure the IP address over there. Okay, you can put the default gateway, not default gateway. Okay, maybe default gateway also. Good. And then you can put about the WLC config, like IP, that this is your WLC. And when you are hard coding it, you can put what is your primary, what is your secondary, what is your tertiary. Three controllers you can configure there through the CLI. This required a console connection. Please be noted. Okay.
Yeah.
Any issues so far?
No, no. It's okay.
So this is whole soul of your, I will say, how AP will get associated with your WLC controller, right?
Okay. Yeah.
One more thing I would like to describe over here. Let us say this is the router. If you are receiving any of the layer 3 broadcast, router will, router or router, whatever you say, will drop it. But we can direct this broadcast if we need using a command IP helper address. Have you heard about this command?
Yeah.
So you can put such an command to avoid maybe such thing. And when you are putting this, your default protocols will get open, right?
Okay.
Like your TFTP, okay, like your TFTP, your NetBIOS, DSCP, and other. If you don't want all the ports to be get opened, you can just put one more command over here, IP forward protocol.
Okay.
Okay, because it use the UDP port 5246 and 5247. You can use those. Getting my point?
Yeah.
So that is how you can do. Again, when you are using your previous old AP, you can erase all the configuration. If you don't want maybe all NVRAM, you can just NVRAM, you can just erase that. Okay. And once it is booted up, you can just take a reload after that. And once it is booted up, it will try to associate with your WLC controller, right?
Yeah.
So when you have the console of your AP, let us say now you have the console of your AP, you can just put over here like CAPWAP AP IP address. These are the command. CAPWAP AP IP address. You can put any of the IP address, whatever you have with the subnet mask, whatever have the subnet mask. Then you can provide CAPWAP AP IP default gateway. And whatever your default gateway, you can put that default gateway. Then you can use CAPWAP AP controller IP, right? I was
Yeah.
talking like the static one you can put, and you can put the controller IP address here. Are you getting my point?
Yeah.
So during that phase, if we capture the traffic through the Wireshark, we can see all of these packets. I will try to I will try to capture it, and we will try to see it. Okay.
Yeah.
In our lab, we will try to find that okay, what all are the options and how to do that. Any doubts so far?
No, no. It's okay.
Fine. Huh?
Yeah. Fine.
Fine. So this is how your AP discovery process will happen. Discovery request and the join request will come. Let me open a slide. Give me a minute.
Okay.
Okay. Can you see my slide?
Yeah.
So I wanted to show you this WLC ports. So you can see there are some service ports, console port, redundancy port. Okay. And there
Yeah.
are some SFP based port named as system ports. These are going to where? These are going to your uplinks. Okay.
Okay.
So when we talk about Cisco WLC, right? There are two terms. One is the interface and one is the port. P stands for port, P stands for physical. So physically, these things are named as ports.
Yeah.
Interface means the logical. So like your SVI in your switches, you create interface, okay, VLAN 20 or bit like that.
Yeah.
Now you need to understand one thing that it can be having physical ports, okay. Physical interfaces, maybe you can say the ports. Logical interfaces are bit like interface. All critical device operations, integration, network infrastructure, everything will uh, be used these two things, right? So
Yeah.
your physical interface is also required. You are aware because you need to send the traffic from where your traffic in, your traffic out will actually go from these ports only, right?
Yeah.
But interface is something like logically where you need to check all of those stuff like VLAN creation you need to create. Then you can see this service port. Service port is bit like your out of band management. OOB. Aware about this?
Yeah.
So this is bit like your OOB, out of band management perspective. You can utilize these ports. Okay. So wireless client will never come to this service port.
Yeah.
Okay. They don't deal with anything. So this is how your ports will be happening. Okay, let me just proceed further. So here you can see the logical interface, what is named as the interface, right?
Yeah.
So logical interface can be there on all maximum all of the WLC controller. You will see all these logical interface. And to make your SSID work, so let us say I am giving one example. You have guest SSID, you have HR SSID, you have employee SSID. Bit like your VLAN, it should be, let us say with VLAN 10, it has the VLAN 20, it has the VLAN 30, right?
Yeah.
What are these? These are the logical interface. So this is a port, this is a port. Let us say this is a port, right?
Yeah.
In this port, there are different
VLANs.
interfaces.
Yes.
These interfaces are associated with your SSID.
SSID.
Are you getting the logic?
Yeah.
So later on, when I will show you the lab, we will create a SSID. I will show you at that time that these all things will come into the picture.
Okay.
Can you see this AP Manager interface? Have you heard about it? AP Manager interface.
Yeah.
What is this?
No, I heard about it, but I don't know what's the use.
Okay. A controller can have one or more AP Manager interface which are used for all of the layer 3 communication between your controller and your lightweight access point after they join the controller.
Okay.
The AP manager IP address, maybe you can say, is used as a tunnel source for your CAPWAP or LWAP packets. and can be used as the destination IP address from your access point to the control. Okay.
Okay. Yeah.
So again, important stuff. So this picture is clear to you, right? If you have
Yeah.
any doubt, you can ask.
No, no, it's okay.
Right. Can you see there is virtual interface? Do you know
Yeah.
what this virtual interface is? Have you heard about it? So virtual
No.
interface is used to manage and support your wireless clients by providing the DSCP relay functionality, especially in your guest web authentication.
Okay.
Okay. It acts as a, maybe you can say, DSCP server.
Mm-hmm.
So
Okay.
your virtual interface IP address is only used for communication between the controller and the wireless client when it need to be get appeared for your DSCP stuff. Although DSCP configuration on the wireless controller itself is not recommended, but yes, if you don't have a separate DSCP server, or maybe if you don't have a lot of bigger client database and you are configuring it on your you know like on your controller, even that will also work.
Okay.
Getting my point?
Yeah.
And as I told you, that this service port of your WLC will be trunk. And you can understand why this should be as the trunk.
Okay.
You understand now why the trunk is there?
Yeah. Yeah.
So that is how you configure your controller in your environment. And that is how, when you configure the access point very first time, what happened to your uh, like how the communication begins from your AP to the WLC. Then you can have link aggregation protocol. Like if you have different ports, this is your WLC, and you have, let us say, I'm just taking two ports, and this is your core, right? So
Yeah.
you can bundle them, link aggregation.
Yeah.
Multiple ports can be configured as a single port, right? So
Yes.
all WLC support the aggregation of multiple distribution ports using a single port. There is a standard named as 802.3D AD, 3AD port standard. Okay.
Yeah.
And you know that your WLC do not support the LACP.
Okay.
So it can be open, neither PAGP. So it should be open from your uh, core side.
Yeah.
Is it fine?
Yeah.
Okay. Fine. Then maybe we can conclude it for today. We will meet next weekend at the same time. Okay.
Yeah.
If,
Sure.
till then, you can go through all the videos and you can just, if you
Yes.
have any doubt, you can clear it. Okay.
Yeah. Thank you so much. Yes.
Yeah. Thank you. Great day.
Thanks.
We'll meet
Yeah.
next
You too.
weekend.
Thank
Take care. Bye.